Welcome back, everyone. Here we are with the first video of section 1.2. So before we start talking about echelon form of a matrix, let's talk about the leading term. So the leading term of a row of a matrix is just the leftmost non-zero entry. So here we go. So given this matrix, boom, leading term, leading term, leading term. And yeah, given this one, these three are leading terms. Boom, boom, boom. Boom, boom, boom. All leading terms. Leftmost non-zero entry, done. If you have a row of all zeros, it has no leading term. Needs to be non-zero. Okay, so then a matrix is an echelon form if the following three things happen. So first, we need all non-zero rows are above all rows of all zeros. Are above all rows of all zeros. Okay, so second, we need each leading term is in a column to the right of the leading term of the row above it. So each leading term is in a column to the right of the leading term or leading term of the row above it. Leading entry of the row above it. So let's quickly take a look at what's going on here. So in this example, there aren't any rows of all zeros, so okay, that's fine. Here we've got two leading terms, one above another. That's an immediate disqualification. You know, we have this one is to the right of the previous one, but this one isn't to the right of anything, it's directly below. So that's a hard pass. That's not in echelon form. Here we're in much better shape. Each time we move down in rows, we move our leading terms move to the right. So we have this nice cascading effect of our leading terms, which is what we want. Okay, and then finally, number three. I think I said leading term instead of leading entry. Okay. I really want leading entry, I think. So that this is what this textbook uses. Oh, let's just fix that really quick. Sorry. Leading entry. I mean, I don't know that it would cause a huge misunderstanding, but best to get these things right. Leading entry. Okay. Right, and then finally, all entries in a column below a leading term should be zero. All entries. I keep on saying leading term in a column below a leading entry. Entry are zero. So again, here we're in trouble because we've got a leading entry and something non-zero below it, whereas this is perfect. We've got our leading entries cascading from top left to bottom right, and all zeros beneath them. Okay, and so we take a look at some of these examples. Here I've just started out where it doesn't matter what the numbers are. If you're in this form, you've got a leading term here and here. They move down to the right as you move down the rows, and there are zeros beneath them. This is perfectly good. This is in echelon form. Same over here. It doesn't matter that there's this big gap between them. The rows of all zeros are at the bottom, also in echelon form. Bam. Here we're in trouble, of course. We've got zeros below our leading terms. That's fine. But this leading term is to the left of that one, which is no good. So this is not in echelon form. Big unhappy face. However, it's equivalent to something in echelon form. All we need to do is replace or interchange row 2 and row 3. And then we're all set. 0, 0, 0. 0, 0, star, star. Okay. I keep on wanting to ask if there are any questions, but of course, I won't be able to hear if there are. So let's move on to an example, see what's going on. Right, so we want to row reduce the following matrix to put it in echelon form. Okay, and since we want a leading entry in this top leftmost position, let's start by swapping row 1 and row 2. It would work with any of the other rows, but we'll start with 1 and 2. Okay, so let's swap row 1 and row 2. And we're left with the matrix 1, 5, 1, 5, 9, 2, -1, 0, 3, 4, 1, 0. And then the last two haven't changed at all. Sorry, this looks like an 8. It's supposed to be a 0. Okay. So next, we want zeros beneath all of our leading terms. So let's use the one we have here to eliminate those two entries. So let's take row 3 and turn it into row 3 plus row 1. Let's take row 4 and turn it into row 4 minus row 1. And let's see, what do we get? So row 1 hasn't changed. Row 2 hasn't changed. Row 3 becomes 0, 6, 8, 2, 0, just by adding 5 and a 1, 9, -1, 2, 0, -1, 1. And row 4 becomes 4 minus row 1. So 0, 2 minus 5 is -3. 5 minus 9 is -4. -2 minus 2 is -4. 1 minus -1 is 2. Okay, so that eliminates all of the terms below our leading entry, our first leading entry. And so we should move to our next potential leading entry. And again, we could choose it to be any of them, but we may as well take this one and try to eliminate everything below it. So let's take row 3 and turn it into row 3. Oops. Row 3 minus 2 times row 2. And we'll take row 4 and turn that into row 4 plus row 2. So 1 and 2 haven't changed yet. 0, 3, 4, 1, 0. 0. So now we've got row 3 minus 2 row 2. So 6 minus 2 times 3 is 0. 8 minus 2 times 4 is 0. 2 minus 2 times 1 is 0. Well, that's fine. 0 minus 2 is 0. So okay. So we've got a row of zeros now. That's the way it goes sometimes. Next, we want row 4 plus row 2. So 0 plus 0 is 0. -3 plus 3 is 0. -4 plus 4 is 0. -4 plus 1 is -3. And 2 plus 0 is 2. Okay, so we're almost in echelon form. The only thing we need to do is swap these two rows, and we're all set. So let's swap row 3 for row 4. Oops. 1, 5, 9, 2, -1, 0, 3, 4, 1, 0, 0, 0, 0, -3, 2, and then all zeros. Echelon form. Right. Row zeros below are cascading leading entries with zeros beneath them. Okay. And we have, so once we've got echelon form, we can find what are called the pivot positions. So these are the pivot positions. They're the location in the matrix of the leading terms, leading entries. So we call, oops, we call the positions of the leading terms, leading entries. pivot positions. The pivots in these positions are 1, 3, and -3. So the values of in the positions. The pivots in these positions. So in other words, the values. Values at these positions. And then the columns containing the pivot positions are called pivot columns. Columns containing the pivot positions. Oops. Pivot columns. And you can talk about having pivot rows too, but somehow that's less interesting. So in this case, the pivot columns are, well, column 1, column 2, and column 4. Okay. Right. So then we could go back and say, oops, not where I wanted to go. We could go back to these pictures and say, okay, pivot, 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 pivot. All right. Okay, so we've done our first example of putting a matrix in echelon form. Let's look back at what we did and write down a strategy that'll always work, or an algorithm for taking a matrix and finding a row equivalent matrix that is in echelon form. So here we've got a strategy for row reducing a matrix into echelon form. Okay, so the first thing we're going to do, the first thing we did even, we start with the leftmost non-zero column. Yeah, start with the leftmost non-zero column. And we want the pivot position to be in the top of this column. So make the top entry a pivot position. Yeah, and then by swapping rows if necessary. So if we go back, that's what happened. That's what we did. We started with a matrix. It had a 0. Yeah, this is our leftmost non-zero column. It had a 0 in the top entry. And since it isn't all zeros in this entire column, we can exchange it with some other column so that this is a non-zero entry. And so we did that. Boom. Okay, leftmost non-zero column. We want to make the top entry a pivot position by swapping rows as necessary. So we know this is going to be a leading term, leading entry. And so we know it's going to be a pivot position. Okay, so then next, we want to use elementary row operations. These are elementary row operations to create zeros below this position. Okay, and indeed that's what happened. We got a 1 in this position. We performed a couple of row replacements to crush with vigor, with power, everything beneath that pivot position. Okay, and then step 3, do the same thing over again, moving one column to the right. Yeah, so repeat 1 and 2, ignoring rows above. Yeah, including including the row containing the previous pivot. So what did we do? Yeah. So then the next thing we did was focus on the like submatrix here and use this pivot to crush those entries. Right. We wanted to, we ignored this first column. Okay. Okay. Okay, and that's our algorithm for echelon form. Come back next time for reduced echelon form. Bye.